Hi guys, welcome back to my YouTube channel. In this video, I'm going to explain about the Codeforces round Div.3 problem F1. Okay, so the problem is called elections in Saransk. Okay, so I think I'm just going to abridge the problem statement. So basically, given an input A1, A2 until AN, and then we can choose, let's say, an array of votes like P1, P2 until Pn, and each P divides there's the respective A. Let's say P1, it will divide like A1. P2 will divide A2. And then ego really likes the number X. However, in the easy version, X is equal to 1. So the problem says is that we need to find how many array that is ideal for this criteria. So like the LCM of all of them is equal to P1 until Pn. So like multiplied. Okay, so the idea is actually pretty simple here. So I will just explain the idea using this simple input array. So 2 and 4. Okay, so the way that we can like construct an array is that let's say we decide to make a prime number here. So let's say 4, right? 4 is like okay, so it can be divided by 2. And then you need to agree that let's say we want to make 2 here, then it will only be another prime array, sorry, another prime number or number 1, but it will not be number 2. So this can only be 1. So let's say we have like 2, 4, 8. Let's say we have here 4, right? Then we cannot make like another form of 2 to the power of x in the other array, sorry, in the other elements. So we can only make 1 and 1 here. Yes, so that is basically the idea. So the details, I will explain it in the code that I've made here. Okay, so first of all, we input everything and then I made a map here and then I will just make a sieve here. Okay, so maybe I'll make a separate video about the details of the sieve here, but basically the sieve will just say like, okay, given a number, find the closest number that is less than equal to this number that divides this and also a prime. So this is basically the sieve. Okay, so while the number of the input is more than 1, we simply just count the frequency, sorry, the maximum numbers that the maximum numbers of power that it can provide. So let's say we have here right 8. So basically in 8, right, let's say we want to pick a prime number equals to 2. Let's say p equals to 2. So how many ways we can pick here is that 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So because all of these are 1, we can have like 3 numbers if we decide to make p equals to 2 in the third element. Okay, so yeah, we just divide it by the sieve, and then we have the answer here. So I'm using a modulo integer here. So this is my template, and then later we multiply the answer by the count of the key, which is like the prime number plus 1. The reason why it's plus 1 is because in here we can also make 2 to the power of 0, but be careful that you cannot like simply make like count plus 1 for the every element here. So everything to the power of 0 should be 1. So that's the special case there. Okay, so yeah, I think that's all for the video. Hopefully you enjoy it, and I'll see you guys in the next video. Bye bye.